Okay, guys, let's see how to find the angle between two lines. For that purpose, we need to know that how to find the angle of a line that it makes uh, with the um, x-axis. Okay, for that purpose you will have to look at this example here. For example, you have, this is your x-axis, this is your y-axis. Okay, suppose you have a line y equal to x over here, y equal to x. Now this point over here is 0 0, and this point is, suppose that is 2 comma 2, and right now we're looking to find this angle theta over here. So guys, if you look at this, if I make a right angle triangle over here, this length is 2 because of this 2, the y coordinate, and this is 2 as well. Okay, so this tan theta is going to be equal to 2 over 2, that is opposite over adjacent, and that is equal to 1. But if you look at this very carefully, this line y equal to x, you will see that the gradient of this y equal to x is also 1. So while finding the angle of a line that it makes with the x-axis, you can simply say that the tan of that angle that it is making with the x-axis is equal to the gradient of that line. So if you have a line y is equal to mx plus c, okay, let me generalize this. There is a line like this, here is the theta. So you can say that tan theta that is equal to m. Tan theta that is equal to m. And if you have a line with a negative gradient, you will have to ignore this negative with the gradient to determine this basic angle over here. That is the first thing. Secondly, this problem on the finding the angle between the line and the axis, or maybe the angle between two lines, that is mostly asked in calculus, in differentiation. So we also learn in differentiation that dy by dx gives us the gradient of a tangent. So if you want to find the angle that a tangent makes with the x-axis, that, for example, that angle is alpha, let's say. So in that case, tan alpha will simply be equal to dy by dx. So this formula of the angle between a line and the x-axis has been modified into this tan alpha that is equal to dy by dx. Okay, so I have drawn an example over here. There is a blue line making an angle alpha with the x-axis. There is a red line making an angle beta, which is 20 degrees with the x-axis. And we want to find the angle between these two lines, which is over here, which is this theta. So this theta is going to be alpha minus beta. You can apply all those trigonometric properties over here to determine that y, this is going to be 50 minus 20, that is equal to 30. Now coming to this question number 15 over here, it says the diagram shows parts of the curves this and this intersecting at the point P. So here is the point P, here is a point P over here, okay? And the point Q, here is a point Q. So these two curves, they are intersecting at the points P and Q. It says the angle between the tangents to the curve at Q is alpha. At Q, that is alpha. So we will find this alpha, giving the answer correct to three significant figures, okay? So this situation here is exactly the situation like this. So you will have to find this angle U, that is the angle this tangent is making with the x-axis, and this V, the angle that this tangent is making with the x-axis, and then you will be subtracting them, okay? So for that purpose, I'll have to clear this area over here so that we can do that differentiation first of all. Okay. Now for this angle U, I will be differentiating this curve with the equation y is equal to half x square plus 1. Okay, bacho, y is equal to half x square plus 1. I get dy by dx, that is equal to x, है ना? And I put that x coordinate 2 into it. So this is going to be at x equal to 2. This m of the tangent is going to be 2. Okay? Therefore, I can say that tan u that is equal to 2. And good students will not be finding this right now, because if you want to write the value of this u, you will have to round it off. So don't do that. Just write this u as tan inverse of 2. Okay. Now let's find the angle V. Angle V is going to be, this angle is basically the angle between the tangent at this curve whose equation is y is equal to square root of 4x plus 1 and the x-axis. So guys, you should be very good at your differentiation. This is half into 4x plus 1 times 4. That is 2 over under root 4x plus 1. Let's put the same x coordinate 2 into it. So you get this m as 2 over 3, Hannah. So your v is going to be tan inverse of 2 over 3. And we have already seen that this alpha is going to be u minus v, the bigger minus the smaller. So alpha is going to be u minus v. Okay, bacho? That is u minus v. Now you put this into your calculators, tan inverse of 2 minus tan inverse of 2 over 3, and you give your answer correct to this required level of accuracy, correct to 3 significant figures. So what is this angle, bacho? Huh? Okay, you can also give this answer into the radians as well, okay, if you want. This is 29.7 degrees. So that is how you find the angle between two lines. And obviously before that, you learn how to find the angle between a line and the x-axis.